Hello everybody, it is 3:30 Eastern Time. Welcome to the second of the GeoMapApp webinars. This one will have a focus on GeoPRISMS, the NSF program that looks at rifting and subducting margins. We're just going to wait a moment for a few other people to log into GoToWebinar, and if people who are logged in now were on the first webinar, we apologize for any service disruption. We only found out partway through the webinar that the company that runs the webinar program, Citrix, was having some problems. And we believe that those problems are now fixed. So Susan Humboldt, if you can hear me and see the opening slide, could you just type something in your questions box there to say that you can hear me and see the opening slide? Okay, we got confirmation of that. Thank you, Susan. So whilst we wait for the last few people to join, this webinar is hopefully going to last no longer than 45 minutes. It might be a bit shorter. And the webinar will be recorded, and we'll place it on YouTube on the GeoMapApp channel there, and hopefully we'll do that next week. So if there's something you don't catch, you'll be able to look it up on the YouTube channel, GeoMapApp channel in the future. Also, if you have questions as we go through this webinar, there should be a questions box in your GoToWebinar panel, and if you type the question in there, my AIDA colleague, Leslie Shee, is going to do her best to try and stay on top of the questions, and we'll try and answer as many as we can. Oh, I should say that my name is Andrew Goodwillie with the AIDA Integrated Earth Data Applications Group at Lamont Doherty Earth Observatory. Okay, so let's get started here. Let me just get rid of this slide, this opening slide. Okay. So I'm assuming that everybody has downloaded and installed GeoMapApp and was checked that it was able to open successfully. So assuming that you have the GeoMapApp icon somewhere on your computer, let's double-click it to open it. Okay, so the format of this webinar, I should say, is probably going to be about 15 minutes or so, if that, maybe 10 minutes, of a brief introduction showing the main functionality of GeoMapApp, and there'll be an opportunity during that time for everybody to follow along by importing a spreadsheet so we can see how that works. And then I can show some of the GeoPRISMS specific functionality and data sets that will be of interest to people who are in the GeoPRISMS community. So if you wish to just watch the webinar for the next few minutes, then that would be fine, and I'll let you know when it's time to practice with the import function. Okay, so here we go. So I double-click GeoMapApp, and the opening screen comes up, and we see we have a choice of 3 different projections: the Mercator projection, South Polar, and North Polar. And for this webinar, we'll stick with the Mercator projection, which is the default, and the default one is highlighted in the blue here. So we hit the Agree button. And the GeoMapApp window opens. So let's have a quick look at the layout of this window. We have the large base map here, and right above the base map we see that wherever we move the cursor, the latitude and longitude position of the cursor is listed. So over on the left, the pair of numbers here shows the longitude and the latitude in degrees and minutes, and the pair of numbers on the right shows it in decimal degrees. At the top of the screen, we see the menu buttons, and for example, under the focus sites, we see an item for the GeoPRISMS program, and we'll be looking at that one in a little bit. And beneath the menus, we see a row of icons, and this is the toolbar. These provide shortcuts or the functionality with which we can explore data. GeoMapApp is a data exploration and visualization tool, and we'll be looking at some of its functionality in the next 45 minutes. Okay, so the first thing is to quickly explain the structure of the base map. What is it that we're looking at here? It's a global digital elevation model that we generate in the AIDA group, and we call it the Global Multi-Resolution Topographic Synthesis, GMRT. In the land areas, we have the Space Shuttle Radar Topographic Mission 30-meter horizontal resolution dataset for the globe. But in the US, we have the higher resolution 10-meter USGS NED, National Elevation Dataset. Although in the Alaska region, that's slightly less resolution than 10 meters. In the oceans, we have a mixture of processed multi-beam bathymetric swath data, as well as contributed grids of ocean depths that were given to the project by a wide range of contributors. And in other areas, we have the Smith-Samwell measured and estimated seafloor topography dataset. So to have a look at the, before I go any further, let me just point out that down at the bottom, there's a listing of all the contributors, and if we click the information symbol, then we see all of the grids that were used for this base map and the countries of origin of those grids. We see the list of swath cruises used to generate the ocean depths where we have swath data, and the links to the bigger data sets that we use, the USGS NED dataset, for example. All right. So let's go and find Mount St. Helens. For that, I'm going to zoom in to the Pacific Northwest. So for this zoom function, we go to the toolbar and we click the zoom in button, the fourth one along. And there are two ways to zoom. We can either click on the map and it'll zoom in one step at a time with each click, or we can draw a rectangle around the area, and when we let go with the cursor, the map automatically zooms. So we can zoom a couple more steps. And here we've zoomed into the Pacific Northwest, and we see Mount Rainier up here, and Mount Adams, Mount Hood, and over in the west is Mount St. Helens. So let's zoom a bit more on this. So now I'm just clicking on the map to zoom in. Go one more step. So it's fuzzy. GeoMapApp is going to the server and it's pulling in the higher resolution tiles, and there we go. Now we're looking at the, in this case, the 10-meter horizontal resolution land elevation dataset. And we see the stunning structure of Mount St. Helens. So at this point, we're just looking at an image that was generated from the actual three-dimensional digital elevation model. And by looking at only an image, we don't really have that much functionality. It would be far better if we could load the underlying data set, and that would allow us to do things like change the color palette, draw contours, and generate profiles across this region. So let's have a quick look at generating a profile in this area of Mount St. Helens. For this, I'll deactivate the zoom tool, and a couple of icons further over, if I let the mouse hover over this one, it tells me that it's the distance profile tool. So we click once on that, and various windows pop up. We see that GeoMapApp is processing the request, and the colors in the map window change there. And when it's finished processing, we'll be able to draw a profile. So just before I draw the profile, let me get rid of the Layer Manager window. Okay, so using the cursor, I click somewhere on the map and drag the cursor and let go, and there's the profile for that area. Let me just move the GeoMapApp window up a bit and the profile tool down. Moving the cursor in the profile window shows the location of the cursor on the profile line on the map as displayed in the little circle or square in the red dot. Also, because we've now loaded the underlying third dimension, the Z value, we see here that that third dimension gridded value is listed. In this case, it's 1,635 meters, and if we go to the summit, we see it's 2461 meters. And in the map window, by moving the cursor around, we still have the latitude and longitude displayed, but over here, just above where the mouse is now, we see the elevation value. And if we have another type of gridded data set loaded, for example gravity, it would give us the value in milligals or so on. Okay, so we can take profiles wherever we want to across this feature, and the profile window instantly changes each time, like that. And if we find a profile and we want to keep it, we can go to the Save button, and now we see various save options. We can save it as an image or even as an ASCII file if we wanted to. Also, in the profile window, we have the ability to use these Start and End buttons to specify exact locations for the start and end of the profile. So the two choices are either to draw on the map with the cursor, as we did, or to type in the values manually and get an exact position. Alright, so I'm going to close the profile window. And one of the other windows that appeared when we loaded the underlying data set was the global grids window, the grid dialog window that allows us to control different actions related to the grid. So the first thing we can do, for example, is change the artificial illumination. Over here on the right is a target-like symbol with a yellow dot, and the yellow dot represents the location of the sun that's illuminating this image. Let's grab that with the cursor, with the mouse, and drag it over, say, to the southeast. And when we let it go, the map quickly changes to show the new illumination. In the middle of the grid control panel, there is a color histogram showing the distribution of elevations with respect to the color palette. And we can change the colors that are shown in the map by grabbing one of these two vertical gray lines, as one here on the right, one over on the left, and moving them sideways. And when we do that, the map will gradually change color, like so. Okay. We're not limited to the color palette on display. If we go to the palettes menu, we see there's a range of palettes available to us. We can even import our own custom-made palette, and we can save the one that's on display if we wish. So, for example, if we're looking at side scan data, we might need to switch to a black and white color palette. So now that we have the underlying grid loaded for this region, we can draw contours, and for that there's a contour button over in the grid control panel here. And when we click it, we get a range of options available to us. The GeoMapApp suggests a contour interval of 100 meters, starting at 500 meters and going up to 2600 meters. But we can change this if we want. Let's say we want to start only plotting contours at 1000 meters elevation. And when we hit OK, the contours will soon appear. There they are on the base map. And we can turn those contours off by clicking that button again. The next button along is the profile button that we've already played with, and if we click it again, we'll just show that, yes, there we can take a profile, just as we did before. And if we want to change the vertical exaggeration to really emphasize the shadows here, we go to the VE box in this part of the window, and let's bump this value up to, say, 3. And when we hit return, there we go. We see that the shadows became more enhanced. If we want to save this window, for example, if we want to base map, we can go to the File menu, and down towards the bottom is the Save Map Window button. And now we see a range of options available to us. We can save the gridded data, or the bottom half shows the various options for saving an image. Okay, so that is shown in just a few minutes how we can quickly interrogate the detailed land and, by similarity, the ocean depth data sets, and generate profiles, draw contours, and save the base maps. Are there any questions on that functionality so far? It doesn't look like we have any questions just yet. Great, so we'll move along. And I should remind everybody that if anything does need to be looked at again, there's a suite of very short GeoMapApp videos on YouTube that shows all of this functionality. So if you don't quite catch something, we can look at the YouTube videos and refresh our memories. Okay, so let's close this window, eliminate the grid, and we do that by going and finding the Close button and hitting Close, and that discards the grid and reverts to the images, which are faster to view over the web than the underlying grid. And going up to the Bookmark menu and pulling down to Zoom to Global Scale will allow us to jump out and look at the whole world once more. So again, I went to Bookmarks, to Zoom to Global Scale. So if you want to follow along using your own installation of GeoMapApp, we're now going to spend a couple of minutes, maybe 5 minutes, looking at importing a spreadsheet, and you could probably foresee yourself doing this in your own research or your own classrooms. And in this case, we're going to find an EarthChem geochemistry spreadsheet. So let me find where I put my copy of the spreadsheet. In here, okay. So I've opened the spreadsheet so we can look at its contents. And this is basically what gets exported from EarthChem. We see that there's a row of column headers. Oh, and if you want to follow along, now's the time to go find your spreadsheet and start following along. And in the first column we have some sample ID information, and crucially we have a latitude and longitude column. GeoMapApp needs those columns in order to be able to plot the locations on the map. Over towards the right we see the geochemical analyses values. So the spreadsheet looks in good shape for importing to GeoMapApp, so let me close it and go to GeoMapApp. And to import a spreadsheet, we'll go to the File menu here. Now before we do the spreadsheet import, let's just look at the other import options that are available. We can import from a web feature or web mapping service, and the other ones that you may be more familiar with are importing a grid file, for example a NetCDF gridded file, such as one that's generated with a GMT or MV system software. We can import a shapefile, a very common geospatial format that's commonly used in GIS communities. And we can also import an image, and for that we have to input the bounding coordinates. And the one we're going to explore just now is importing tabular data in the spreadsheet. So we select this and we go over to the right and we choose the option for an Excel formatted spreadsheet. It's the fifth one down. And the navigation window pops up, so we have to go and find that spreadsheet. So off we go. Oops. Click on there. Spreadsheet. And here's the spreadsheet that we just viewed. So we click Open, and GeoMapApp tells us it's reading the file, and there it is. It's already read the file, and it's put the contents in here, so we hit OK. And this window wants us to check that the latitude and the longitude columns have been correctly identified. Had we called the columns something else, then we would just use the drop-down menu here to identify those columns. And at this point, we'll just hit OK. So three things happened. The symbols appeared on the map over in the Western Pacific. This is a spreadsheet of the geochemistry for some Marianas rock samples. On the right, we see a control panel with some buttons that we'll explore in just a sec. And down in the bottom, we see a record, an area where the records that were in the spreadsheet are listed. So what we can do, we can zoom into the area. So we'll click on the zoom in button and we can go and zoom in. Let's go a little bit further in. There we go. And I'll just deactivate the zoom because I'm bound to click on the map and I don't want to mess anything up. And we can click in the table below to highlight the symbol, the relevant symbol in the map. So if I click down here, we can see the symbol is being chosen in the map by a red circle. Or we can go the other way and select one of the circles on the map and show it down below. There's also the option in GeoMapApp to plot the symbols in different shapes. There's squares, triangles, stars, and a couple of other ones. So you can import many different data sets and have them as different symbols. And if anyone's looked in recent GeoPRISMS newsletters, the data portal report, you'll see some of the maps I've made with the multiple types of symbols there. So at the moment we're just looking at gray dots on a map. Let's go over to the control panel on the right and do something with the data that was contained in that spreadsheet. For example, one of the things we can do is color the symbols. So when we hit the color button over on the right, this window pops up and we choose which column we want to color on. So let's color on Alumina, say, AL203, and hit OK. And the symbols change color, and a color palette window opened here. And just like when we had the grid loaded for Mount St. Helens, we see these two gray lines, and we can use these to change the range of colors on display, like that. Very easy. So that's a quick way to look for color patterns in the data set that we just imported. Another thing we can do is scale the symbols according to another column in the data in the spreadsheet. So let's hit the scale button, and let's say we want to scale on MgO, magnesia. Hit OK, and a scaling window appears, and we can change the scaling range like that. Okay. So here we have the imported geochemical data set, and we've colored it on one of the columns, and we've scaled it on another column. All the while we're looking at it in its correct geospatial context. We can also graph any two of the columns together. If we hit the graphing button, we choose what we want to plot on the graph. So for the x-axis, let's do, say, silica, which is here. And on the y-axis, choose something, let's do, say, iron oxide. And here we have the values. We notice straight away that the symbols are different sizes and different colors in this graphing window, and that's preserved the coloring and scaling from the map window. If we want, we can change the range of data on here by clicking and dragging on the blue line at the borders, like that. And we can use a lasso tool up here, activating the lasso tool, and with freehand drawing we can select symbols, a range of symbols on the graph. By using the lasso tool like that, all of the selected symbols, records, have been highlighted in the table below, and not all that easy to see on the GoToMeeting screen probably, but all of the symbols that were selected have also been ringed in white on the map. And that selection that we've grabbed with the lasso tool can be saved using the Save button down here in the right panel. So for example, if these were anomalous data points, you could send them off, save them as a spreadsheet and send them off to a colleague, for example. Okay. So that's one example of importing a tabular data set, in this case an Excel spreadsheet of geochemistry, but you could imagine it could contain anything. It could be sea surface temperatures, populations, whatever you want, it doesn't matter. So now I'm going to quit this tabular import function. I close that. Oh, and we just had a question, does the Excel spreadsheet or any tabular data file need to be in any particular order. No, it doesn't. You can have any column in any order, and as long as the column headings are there, GeoMapApp will do its best to identify the latitude and longitude column. Great question. I also forgot to mention that clicking on the column headings once the table has been loaded in GeoMapApp will sort the data. Okay. Any other questions on that example of importing a data set? Just a sec, we have another question. There was a question about, can you create a color legend? Yes, you can. And so as you color the symbols with GeoMapApp, there's an ability to click a button to create a color legend, and we have that on the YouTube videos. And I can respond to that particular webinar participant with more details. Good question. Okay, so I'm going to go back to the world view, bookmarks, zoom to global scale, and you may want at this point just want to watch what I'm doing. I'm going to load a bunch of different data sets and show how the layering functions can be used to compare many different data sets in one particular area. So for this, let's go back to the menus, the focus site menus, and we're going to look at the contents of the GeoPRISMS focus site menu. So just to make it a bit easier to navigate in the menu structure, I'm going to select the tear off menu option at the top. And by doing that, I get a separate window, and it just makes for a little bit easier navigation. So here I go into the GeoPRISMS program menu item, and let's go into Alaska. So we see there are some options under here, and under tables, I'm going to look what's under there. So we can see that for this particular primary site, this GeoPRISMS primary site, one of the 5, it's pre-populated with a range of different data sets. There's some Earth scope, seismometer, and GPS locations. There's a Canadian National Seismographic Network, and there's a couple of PI-driven seismometer deployments here. So let's have a look, say, at the Moose operation. So we'll select Moose down towards the bottom, and we'll hit OK. And we see that the GeoMapApp window takes on the format that we saw a little bit earlier. We have the control panel over on the right, and the table of information down at the bottom. If we make the column wider, we can see we have some links in there. So let's zoom to the area of these points up in Alaska. So there are a couple of ways we can zoom. We can either zoom with the zoom button, as we've already done a couple of times, or if we find the layer manager window, which may be parked in at the bottom of your computer. If it doesn't exist, you can just hit the lastmost icon in the toolbar, and that will bring up the layer manager. And you'll see that there's the zoom in button associated with the Moose item. If we click this, then we're taken right into that area. And I'll minimize the layer manager. Let me just budge down a little bit. Okay. So here we see the seismometer stations are overlain on the high-resolution Alaska topography here. And if we select any of these symbols, it shows us which seismometer we're talking about. And let's choose, say, this one. And if we hit the link that's in this built-in table, this will bring up, hopefully, there. It brings up the link to the IRIS data center station summary page. And from there, we can go and download the data down in the bottom. Okay, let me minimize that. And we've done that type of linking with many of the built-in data sets. So that's a very quick way where a researcher can import their own data sets, for example, and put it in on top of the high-resolution base map for further analysis. So let me close this data set, and I'm going to zoom out a few steps so we look at a wider area of the Alaska-Aleutian arc. So I'll hit the zoom out button and click the map a couple of times. Okay. Now we can see the whole of the Alaska-Aleutian primary site up here. And I'm going to go back into the focus site menu, which we have open here. And I'm going to choose the EarthCam data down at the bottom of the tables menu. So we already looked at EarthCam, an example of EarthCam data for the Marianas region. Now we're going to look at it and start layering it for the Alaska area. So this is a much bigger file. There are many, many more samples. Oh, in fact, GeoMapApp tells us there's way more than 10,000 stations in this table, and it's just alerting us to that fact. So we hit OK, and there they are. Now, every single point has not been plotted on the map. However, when we zoom in, the points will start to appear. We limit the number to 10,000 just because it's hard to keep track of all 10,000, more than 10,000 points if a user pans around or scrolls on the map. So let's zoom in a little way, and we'll go, say, here. 160 west is roughly the area of the Shumagin Gap, and we see the symbols highlighting the EarthCam geochemical analyses for these particular rock samples. And just like before, we can color and scale the symbols. So let's just quickly color them on one of the values, say iron oxide. Okay. So this is just like we did for the Marianas one, where we practiced importing our own table. And like before, we can change the color range, like so. All right. So here we've got the Alaska geochemistry overlaying on the base map. And wouldn't it be nice to look, say, at the subducting slab? Can we access a data set that gives us the depth to the top of the subducting slab? Yes, we actually have that built in. Alan Syracuse and Jeff Abers very kindly donated the grids from their 2006 paper that gives the depth to the top of the slab. And for that, I'm going to go into the base maps menu, and under regional grids, if we pull down to the bottom, we have an item called the subduction interface depth. And there's Syracuse and Abers, and there's the Alaska-Aleutians item right there. We could also navigate to this menu by clicking the tear off menu item right at the top of the list, just like we did for the focus site. So GeoMapApp is it's already loaded the grid that gives us the depth to the top of the subducting slab here. Now, as I move the mouse, let me zoom in a bit so we can see a bit more detail. Okay, and actually I'm going to get rid of the map inset up here. That's taking up a bit of space, so I go to Overlays and untick the map inset button. There we go. So we see that the data set we just loaded, the grid giving us the depth to the top of the slab, is overlaying on top of the base map and on top of the geochemical symbols. Well, that might be okay for now, but we might want to bring the geochemical values back up to the top. So let's do that. Let's go back to the Layer Manager, and remember there's a shortcut to the Layer Manager right here, clicking that last icon on the toolbar. And here we see that the Alaska-Aleutians subduction depth grid is listed at the top, followed by the geochemistry data. Using the arrows over on the right, we can promote a data set up to a higher level or down beneath another one. So let's click once on the up arrow, and there we go, we brought the geochemistry back on top. And I'll just minimize that Layer Manager window. So we have a grid loaded, and as we move the mouse, let me turn off the zoom button just in case. As I move the cursor around in the map window, we'll see that over here where there's no grid, we don't have any depth value for the subducting zone depth, but when I move the cursor on top of the grid, then just up here right above the mouse there in the top bar, we see that the depth to the subducting slab at that position is listed. So let's take a profile across this grid. For that, I need to go find the grid control panel window that we looked at earlier, and I need to activate the profile tool from here. When we looked at Mount St. Helens, we hit the profiling tool up here, and that is actually a shortcut to the topography data, the global digital elevation map. But now I want to take a profile across the data set we just loaded at the subducting slab depth, so I need to select the profile tool from here. So here we go, I'll click once on this, and now the cursor is active. And drawing a profile from the northwest down to the southeast shows us the depth to the top of the subducting slab beneath the Alaska-Aleutian arc there. And as we move the mouse around in the profile window, we see the depth is listed right here. Okay. So let's say we want to save these images, the profile window and the map window. For the profile window, we can hit the save. We see the save functions here. And for the map window, if we go to the File, Save Map Window option, we have the options to save in different formats. So that might be useful if you're making a picture for a GU poster, for example, or a paper. Okay, so now we could add another. I'm going to kill this profile window, and I'm going to layer another data set on top of this area. And in this case, I'm going to plot the focal plane mechanism solutions, the earthquake dataset CMT solutions from the CMT project. These values are located under the Portals menu, and it's the second item down, Earthquake Focal Mechanism Solutions. So if we click on that, it takes a moment to load the dataset, and we see a whole load of little blue dots appeared. Well, if we actually zoom in a little bit more, those blue dots should change into beach balls. There we go. So I clicked them at once and went in a little bit further, and we now look at the beach balls. So here we see the thrusting solutions. So in this image, we have 4 or 5 different data sets. We've got the base map, here's the bathymetry, and the green shows the land elevations. We have the depth to the top of the subducting slab. Overlaying on that is the geochemical analysis from EarthCam. And the last one, most recent one we loaded, was the focal plane mechanism solution data set shown in the beach ball as the beach balls here. And again, we can save that as an image if we wish. Now, we can also load even more data sets, and let's just have a quick look at the Layer Manager to see how we're doing. So the Layer Manager keeps track of all these different data sets, and we can promote or relegate some if we so wish, but we'll just leave them as they are for now. But there's some high-resolution data in here too for the bathymetry and land elevations, and it actually comes from the tsunami warning project that was undertaken by the USGS and NGDC. So for this data set, let me first turn off the zoom in button, and I'm going to go under back to the focus sites menu, and I'll minimize the tables, and in this case I'll look at the bathymetry grids. And we see some options here. These top 2 are the extended continental shelf surveys. And under here, under US-based coasts and estuaries, we see a link to Alaska. And let's say, we're going to load the sand point grid. But before I do that, I just want to preserve this map area that's currently on display. So in order to lock the boundaries, the borders of the map, I go to the grid control panel, and at the top you'll see this padlock button. And if I let the mouse hover over it, it says click to lock the displayed map area. So that can be really useful. If we did not click that when we load the grid, we would zoom to that particular grid, so we'd lose this particular display area. So let's just click once on that padlock, and now we've fixed the area on display. Okay, so now I'm going to go to Sandpoint and select it, and we see that it's a 10-meter resolution grid, so it's very high resolution for this part of Alaska. And we hit OK, and I'll bring GeoMapApp back to the front. And right here, we see the bathymetric grid was loaded. And we could, if we wish, zoom in and see more detail. So let's have a look. Like so. And just like we saw before, we can change the transparency. I think I showed the transparency. I hope I did. If not, we'll look at it right now. Let me click off the zoom button, and I'll go find the grid window. Here it is. And here I'm going to do a couple of things. Actually, sorry, I'm in the wrong window. I just got ahead of myself. I need to find the Layer Manager window, which is up here. And with the Sandpoint grid, we can slide the transparency, slide the opacity scale bar, and compare it to the underlying information. In the same way, we can slide the scale bar for the slab subduction depth and compare the data sets like that. Sorry for not showing that earlier, I forgot. Okay, so let's bring those geochemical data points back onto the top layer. So we go find them in the Layer Manager, and we click the arrow at the top, and we go one more, and there they are. So now we have the depth to the top of the subducting slab, the geochemical data, and the high-res land and sea elevations there. Okay, there was a question that came in, is there a way to take a profile across two layers? Currently there is not, unfortunately. You get a profile of the layer that is the grid layer that's currently active. So that's a good question. That's something that we can add to the list and consider what it would take to program that in. Okay, so are there any questions on that sort of functionality that I've just displayed? If I zoom out a couple of steps, then we'll see a map that could be useful for our studies. So just wait a second, see if there's any questions. Okay, it doesn't look like there's any questions so far. Hopefully I didn't lose everybody. Oh, a question's just coming in. Hold on a sec. Oh, the question is the ordering of the layers. Whenever we load a new layer, whatever it might be, whether it's a built-in table or grid or an imported table or grid or shapefile, it always loads on top as the topmost layer, and we need to use the Layer Manager window, this window here, to promote or relegate things accordingly. So if we wanted just to look at one layer in particular, we'll bring that one up to the top. Hopefully that answers the question. Okay, so in the last couple of minutes, we'll look at some of the other built-in data sets. So in order to do that, I'm just going to close some of the things I've got open here. So I'll close that window, I'll close that one. In fact, if we get confused and we have too many windows open, we can just kill GeoMapApp completely and then go back and double-click on the icon on the computer and restart afresh. And that might sometimes be the faster way to do it. Okay, so we're back to where we started. So let's have a quick look at some of the built-in data sets. One of the ones that's in there is the Smithsonian Global Volcano Program dataset, the catalog from that. and that's listed under data sets, and this might be of interest to GeoPRISMS folks, under volcanoes and seamounts, and we see that the link is there. It loads the table, and we see the dots have appeared on the map, and we're now familiar with the structure of the window. And the volcano names are here. We can sort some of these, so let's sort them by, say, elevation. Why not? There we go. Ooh, so there's some very high ones there. We could sort them by latitude, say, and so on, or by name, like that. And let's go and look, say, at East Africa, one of the other GeoPRISMS focus sites, our primary sites. So here we are. I'm zooming in a little bit. Here's Lake Victoria, and GeoMapApp is pulling in the higher resolution data. I go back to the cursor, so I'm no longer on the zoom function. If we click on this one, we see that it's Kilimanjaro, and if we click this one, we see it's Mount Meru. And if we follow the link in the table, this should bring up the Smithsonian. Did I click it? Oh, there we go. The Smithsonian record, Smithsonian webpage for Mount Meru. There it is. Okay. So another data set that we have built in, let me just go back to the world scale, are the earthquake catalogs from the USGS NAIC, National Earthquake Information Center. And they are also under data sets under earthquakes and plate boundaries. And again, we can click on the tear off menus option. That might be a bit easier for navigation. And we select the earthquakes and earthquakes NAIC. And let's choose, say, the catalog that spans a 40-year period of all the earthquakes greater than magnitude 5.5. And when we hit OK, it will load these on top of the previous layers. And like before, it tells us that it's a big file, so we hit accept, and there we go. So if we want to do something with these earthquake value positions that we just loaded, we can, say, color the symbols according to depth. So we'll hit we went over to the right, we chose color, and we hit OK. Let's zoom this over here. And here we see that the white colors are the deeper earthquakes and the blue cooler colors are the shallower ones. Let's zoom to the Pacific Northwest. Now the gray symbols that are in here, that's the underlying layer of the Smithsonian Volcano Program catalog still. If we want to turn that layer off, we have a couple of options. If we go to the Layer Manager window by bringing this up, first I have to select it, so I need to go in, let me just kill that. I need to go to the right and I need to choose the Smithsonian table, that's the one there, and now I can find my Layer Manager window, and now I can untick that box or use the transparency slider to make the values transparent. So there we go. And now I go back and I choose the earthquakes, and there are the earthquakes. Okay, so the earthquakes are color-coded according to depth, and now I can scale them according to, say, magnitude. That would be the obvious thing to pick. So here the symbols are scaled according to the size of the earthquake, and we can see that the bigger the symbol, the bigger the earthquake, like so. We can also load the lithospheric plates for this area. That's one of the other built-in data sets. For that, we can go to Base Maps, and we pull down to the Geophysical Maps, and the World Lithospheric Plates is right here, this data set. And using the Layer Manager, I'll budge that beneath the earthquakes, so we can start to see how the lithospheric plates, earthquakes, and volcanoes are all related. And if I was to zoom out to the global scale, and we'll wait for there we go, you could see that if you, for example, teach intro geology, this might be a useful tool to look at plate tectonics. Okay, so a question just came in, and it's a great segue from what I just said. Are there any activities for education? Actually, there are, and if you go to the Education menu, under Student-Centered Learning Activities, there's a whole bunch of them. There's some Earth Exploration Toolkit chapters. I had received some funding from NSF to generate a collection of activities. For example, if we look at the suite of activities here, there's one on seafloor spreading, landscape regions, Hawaiian Islands, hotspots, and plate motion, and so on. So yes, there is a range of activities that are ready to go, off-the-shelf activities. Another question came in: if you save a map, can you later reopen it and make changes? At this point, no. However, we are in the process of developing a function that will allow us to save the session. And when that function is active, it will preserve everything that we've done in the GeoMapApp window, so we can come back to it at a later time, and when we open that file, it will get us right back to where we were. So that is on the to-do list, and it's in development. So thank you for that question. Okay, the last thing I want to show is I'm going to get rid of these data sets that we've so far plotted, go back to the original map window like that. And I'm just going to quickly show in the last minute one of the portals, and this one is for multi-channel seismic data. And in GeoPRISMS, there's a lot of data in the primary sites, and we'll look quickly up in the Alaska region. So I go into portals, and I find the digital seismic reflection portal, and it will load in a second. There it is. Each of these rectangles shows the location in which we have MCS data sets. So I'm going to choose this one up around Alaska, and I'll zoom in a little bit more. There we go. So here we are on the right over the arc, and I'll turn off the zoom button. And in this case, the layout of the GeoMapApp window is again changed. We have a new control panel over on the right and some empty panes down in the bottom. And if you don't quite catch all of this, we'll be going over the portals function in the 4th webinar tomorrow afternoon. And it also already exists on the GeoMapApp YouTube channel. So here, I'm going to click one of these lines. These lines show the profile track lines for MCS data. So if I select one of the lines, it turns white, and over in the right it shows me that it's a Ewing leg from 1994, leg 9, and in this particular case this is MCS line 1232. Hitting the load view 1 will go to the server, and it will pull in the MCS profile for this line. So it takes a moment to load. And here it is. Okay, so it's loaded it over in this window. I zoom, and we start to see more detail. So here are the reflection horizons. The y-axis is in two-way travel time, and listed across the top is the common midpoint gather number. Also, if you look on the map, there's a little red part on the track that is otherwise yellow. The red part shows the extent of the profile that's shown in the lower left pane. So I can load another profile, and for that I'll click this line here, the one that goes across the first line. This shows me that it's line 1234, and I'll load it in view 2, and it should load in this region here. This is a longer profile, it might take another few seconds. There it is. Okay, and again we'll zoom in and look for some structure. Okay, so here in this portal we can see that in no time at all we loaded 2 multi-channel seismic profiles, and by using the scroll buttons, scroll bars, we can quickly interrogate the data. We can even digitize these horizons in the reflection profiles. So let's just show one quick example of that. I'll oh, hold on, I need to, yep, I had to deactivate the zoom button. So I activate the digitize function, and I can now go in and click on the map, and depending on how good a shot I am with the mouse, okay, so there's a profile horizon that I've digitized, and I can save the digitized file, and it'll save the two-way travel time and the CMP number and the latitude and longitude. We can also save the profiles that are shown in the screen, and for that, if we go to the diskette over on the left and click that, we have various options for saving the file. We can even download the segY file itself from the website. Okay, so I think I'm just about out of time here, and I will say that if you need any help, there's a help button in GeoMapApp up here on the right, and there's a mechanism, the comments and suggestions, to send feedback to us. We try to be very responsive to feedback. And there's also a link here to the multimedia tutorials that I've mentioned a couple of times. If I click that link, it brings up the GeoMapApp webpage with all of the links to the YouTube videos, like so. So there are hundreds, if not thousands, of built-in data sets in GeoMapApp under these different menus up here, and I invite you to explore as much as you wish. And the last thing for me to say is thank you very much for your attention. This webinar is being recorded, and we will place it on the YouTube page hopefully by next week. And of course, if you have any questions, please send us email and we'll try to respond. So I'll just wait for one moment to see if there's any more questions.